A number 4 copper concrete encased electrode, commonly referred to as a CEE, with a minimum of 20 feet contact with the footing, indeed has to be continuous to the panel. This requirement stems from the fundamental purpose of the CEE, which is to establish a continuous electrical pathway between the grounding electrode system and the electrical panel. Any discontinuity or break in this pathway can compromise the effectiveness of the entire grounding system, potentially leading to unsafe conditions. The concrete encased electrode acts as a primary grounding electrode. It is typically installed within or near the concrete foundation of a building or structure. Its purpose is to provide a low impedance path to earth for fault currents and to help stabilize the electrical potential of the grounding system. The requirement for continuity ensures that the CEE can effectively perform these functions. When a fault occurs in an electrical system, such as a short circuit or ground fault, the fault current needs to be safely conducted back to the source. The grounding electrode system, including the CEE, provides a low impedance path for this fault current. A continuous CEE ensures that the fault current can flow unimpeded from the electrical panel through the grounding electrode conductor to the CEE and then to the earth. If there is a break in the continuity of the CEE, the fault current may encounter higher impedance which can impede its flow. This can result in elevated voltage levels on conductive surfaces, increasing the risk of electric shock. Furthermore, a discontinuous CEE may not be able to effectively stabilize the electrical potential of the grounding system. The grounding system is designed to maintain a relatively stable reference point for voltage within the electrical system. This helps to prevent voltage fluctuations and transients that can damage equipment or create hazardous conditions. A continuous CEE helps to ensure that the grounding system is properly connected to earth, which helps to stabilize the electrical potential. The National Electrical Code, or NEC, provides specific requirements for grounding electrode systems, including CEE. These requirements are designed to ensure the safety and effectiveness of electrical installations. It is important to consult the NEC and local electrical codes for detailed information on the installation and maintenance of CEE and other grounding electrodes. The requirement for a continuous CEE is directly related to the effectiveness of the grounding system. Consider a scenario where a building's electrical system experiences a ground fault. If the number 4 copper CEE is continuous from its 20-foot contact within the footing to the electrical panel's grounding bus, the fault current will have a clear, low impedance path to earth. This allows protective devices, such as circuit breakers or fuses, to quickly detect the fault and interrupt the circuit, minimizing the risk of electrical shock or fire. However, if the CEE is not continuous, perhaps due to a break in the copper conductor or a loose connection, the fault current will encounter a higher impedance path. This increased impedance can slow down the fault current, delaying the activation of protective devices. In this scenario, exposed metal parts of electrical equipment or appliances could become energized, posing a significant shock hazard to anyone who comes into contact with them. Moreover, the prolonged flow of fault current through the high impedance path can generate heat, potentially leading to a fire. Therefore, maintaining the continuity of the number 4 copper CEE is paramount for ensuring the safety of the electrical system and the occupants of the building. The continuous path provided by the CEE allows for the rapid and effective clearing of ground faults, minimizing the risk of electrical hazards. Several factors can contribute to the discontinuity of a CEE. Firstly, physical damage to the copper conductor can occur during installation or construction activities. For example, the CEE could be accidentally cut, bent, or crushed, creating a break in the conductor. Secondly, corrosion can degrade the copper conductor over time, particularly in harsh environments. Exposure to moisture, chemicals, or dissimilar metals can accelerate the corrosion process, eventually leading to a break in the conductor. Thirdly, these corroded connections between the CEE and the grounding electrode conductor can also create a discontinuity. If the connection is not properly made or if it becomes corroded, the electrical path between the CEE and the panel will be compromised. To prevent discontinuities in the CEE, several precautions should be taken. Firstly, carefully inspect the CEE for any signs of damage before installation. Ensure that the copper conductor is intact and free from any cuts, bends, or crushing. Secondly, protect the CEE from physical damage during installation and construction activities. Use appropriate supports and protection measures to prevent the CEE from being accidentally damaged. Thirdly, use corrosion-resistant materials for connections between the CEE and the grounding electrode conductor. Ensure that the connections are properly made and tightened to prevent loosening over time. Fourthly, periodically inspect the CEE and its connections for signs of corrosion or damage. If any problems are detected, take corrective action immediately to repair or replace the affected components. The NEC provides specific requirements for the size and type of grounding electrode conductor used to connect the CEE to the electrical panel. The size of the grounding electrode conductor is based on the size of the service entrance conductors. The NEC also specifies the type of material that can be used for the grounding electrode conductor, typically copper or aluminum. The grounding electrode conductor must be securely connected to both the CEE and the grounding busbar in the electrical panel. The connection must be made using approved methods such as listed connectors or exothermic welding. The NEC also requires that the grounding electrode conductor be protected from physical damage. This can be accomplished by running the conductor in conduit or by using other appropriate protection measures. In addition to the CEE, other types of grounding electrodes may be used, such as ground rods, ground plates, and metal water pipes. The NEC specifies the requirements for each type of grounding electrode. It is important to select the appropriate type of grounding electrode for the specific application and to install it in accordance with the NEC requirements. The proper installation and maintenance of the grounding electrode system is essential for electrical safety. A properly grounded electrical system helps to protect people from electric shock, prevents damage to equipment, and reduces the risk of fire. It is important to consult with a qualified electrician to ensure that the grounding electrode system is properly designed, installed, and maintained. The electrical panel acts as the central distribution point for electricity within a building. It receives power from the utility company and distributes it to various branch circuits that feed lighting receptacles and appliances. The electrical panel also houses the overcurrent protection devices, such as circuit breakers or fuses, which protect the circuits from overloads and short circuits. The grounding busbar in the electrical panel provides a common connection point for all of the grounding conductors in the electrical system. The grounding conductors from the branch circuits, the equipment grounding conductors, and the grounding electrode conductor are all connected to the grounding busbar. This ensures that all of the conductive surfaces in the electrical system are connected to earth, providing a low impedance path for fault currents. The grounding busbar is typically made of copper or aluminum and is securely mounted to the metal enclosure of the electrical panel. It is important to ensure that the grounding busbar is properly sized and that all of the connections are tight and corrosion-free. The electrical panel should be inspected periodically to ensure that the grounding connections are in good condition. Any loose or corroded connections should be tightened or replaced immediately. The NEC requires that the electrical panel be properly labeled to identify the circuits and the overcurrent protection devices. The labeling should be clear and accurate so that electricians and other qualified personnel can easily identify the circuits. The electrical panel should also be protected from physical damage. It should be located in a dry and accessible location and should be protected from impact or other hazards. The electrical panel is an important component of the electrical system and should be treated with care. Only qualified personnel should perform work on the electrical panel. The NEC provides specific requirements for the installation and maintenance of electrical panels. The NEC also provides requirements for the spacing and arrangement of conductors in the electrical panel. The conductors must be properly supported and secured to prevent them from coming into contact with each other or with the metal enclosure of the panel. The NEC also requires that the electrical panel be properly grounded. The grounding electrode conductor must be connected to the grounding busbar in the electrical panel. This ensures that the electrical panel is connected to earth, providing a low impedance path for fault currents. The NEC is a comprehensive set of standards for electrical safety. It is important to consult the NEC and local electrical codes for detailed information on the installation and maintenance of electrical systems. Grounding is a critical aspect of electrical safety. A properly grounded electrical system helps to protect people from electric shock, prevents damage to equipment, and reduces the risk of fire. It is important to consult with a qualified electrician to ensure that the electrical system is properly designed, installed, and maintained. Maintaining the continuity of the number 4 copper CEE is a fundamental requirement for a safe and effective grounding system. The CEE provides a continuous electrical pathway between the grounding electrode system and the electrical panel, ensuring that fault currents can be safely conducted to earth. Any discontinuity or break in this pathway can compromise the effectiveness of the grounding system and increase the risk of electrical hazard. Therefore, it is essential to carefully install and maintain the CEE to ensure its continuity and proper functioning. Firstly, the CEE needs to be continuous to the panel to provide a low impedance path for fault current. Secondly, if the CEE is not continuous, the fault current may encounter higher impedance which can impede its flow. Thirdly, a discontinuous CEE may not be able to effectively stabilize the electrical potential of the grounding system.